Hello, everyone. Welcome to the second module. In this module, we will focus on the fundamentals of data visualization, data modeling, and dashboard design. In this video, we will look at several examples. We will compare and contrast those examples to show how design choices can distort the data or hide it completely. We will discuss complexity and simplicity in data visualization. So we will look at several bad examples of data visualization. And the purpose of this video is to demonstrate data visualization through comparing and contrasting examples. We'll show several real examples to look at the inappropriate use of specific attributes in the data visualization kind of charts and specific examples. So first, this chart was created to visualize the guesses of someone's height and the weight from a picture. The picture was posted online, and readers of this blog guessed the height and the weight. Here you can see a white dot. It represents the woman's actual height and weight. So can you actually interpret this chart to understand how we actually should understand the meaning of this chart? So even though you can see a color legend placed on the right-hand side, it's still very difficult to understand what the author wanted to convey to the audience. So here is the blog website. Not this one. Here is actually the blog website still exists. It was created in 15 years ago, actually 2007. So this is an image posted on the blog website. And then the author asked people to guess this woman's height and weight. And then he created this chart. So even this person the author of this data visualization even admit that, to be honest, I'm not even sure how you're supposed to read this graph, and I'm the one who made it. So because this person was not trained in creating data visualization, so even she was confused on how to read it. So actually a dot plot can be easily used to replace the previous chart to make it easier to read, to interpret. So a similar example is from this website called height-weight-chart.com. This website shows a scatter plot of height and weight, but uses pictures of people instead of dots. Users can upload images of themselves matching various heights and weights. So you can even click on the height and weight and see what the people look like. So the website still exists. So if you go to this website, it looks like this one. So you can actually click each image to look how this person look at each person's image. So this is an interesting way to use image instead of dots to present this dot plot. So the previous example was the wrong chart type. So let's look at this example. So we know this is a bar chart. So the chart type isn't the problem. But what do you think the problem is in this example? We actually see this kind of chart this type of example a lot in data visualization. So the first thing people do when they look at this type of chart is to rotate their head and try to read the labels. This is not very helpful, especially when the labels are pretty long. So what do we do? So for bar charts, they can speak both vertically and horizontally. So which means you can just rotate the chart instead of asking people to rotate their heads. So now the length of the bars are just as easy to compare, and now the labels are easy to read. So we don't need to rotate our head to read those long labels. So this chart was featured on recovery.org before the website was taken down. So they felt the data should come off the page at you. That's why they use this 3D chart type, 3D bar chart, instead of 2D. So there's lots of what we call digital ink needed to create this type of 3D effect. So later on, we are going to talk about the concept of digital ink. So essentially, we want to minimize the use of digital ink. So this affects the way that we perceive the information, and it makes comparisons very difficult. Especially, it's almost impossible to make precise comparison. So another example from the same website, recovery.org. So if one 3D exploding pie chart isn't bad enough, so they added another actually 3D exploding pie chart. So notice the extra digital ink in this case, the slice in the front of the pie chart will have extra ink, making the slice up front much bigger than the poor slice in the back. So this is actually doesn't make it very precise, especially for those different slices in these two pies. So this example is no longer online, but you can still read the post on some website if you're interested. So this person decided to visualize Google's financial results in a much more exciting, clear, and graphic way. So let's see if you agree that this is exciting and clear and graphic. So here is Google's quarterly revenue growth. We see lots of issues here. So labels, we see of each other. The color choices are not bad. The quarters are listed on the bottom on the chart without year. So without the subtitles at the top, we would have no idea what the years are being displayed. So the most interesting thing here is the y-axis. So we've never seen someone plot the y-axis in such interesting increments. It's hard to imagine that plotting in increments of 10.7145% would be useful to anyone, and then after using such a precise number to then round to 2 decimal places on the y-axis, and then no decimal places on the data labels. So this one goes even further with the data labels. They are plotted on top of everything now. So we see a lot of overlaps. So finally, another interesting example, even more data labels making it impossible to read anything. So you can see they actually decided to put the y-axis in units of $1K to avoid adding 3 zeros to those numbers. So now look at this example. It's actually from Fox News. So what's wrong with this one? So it's from 2011. The data source is from Bureau of Labor Statistics. It shows the unemployment rate under President Obama. So it looks like there's nothing wrong, but if you look at the last data label, 8.6%, it seems to be the same as 9.0%. So in this case, this chart is not correct. It's not plotted correctly. So this example comes from SAS. So we all know SAS is a pretty well-known company. So they actually try to create this chart to impress maybe the stakeholders about their achievements. But in this way, it's actually difficult to interpret the data. The data visualization actually talked about this a lot. So even some people actually, some people like Stephen Few, they commented on this one. So later on, SAS realized the issues in this 3D line chart. They actually blamed this on the marketing department. And then they did this again with this simple line chart. So this redesigned line chart was eventually used in the press release and presentations. So now let's look at a famous visualization we talked about before. So this is from Charles Minard. So Edward Tufte called this possibly the best statistical graph ever done. So before we discuss this, let's take a minute to understand it. So it's a visualization of Napoleon's campaign into Russia. It's created by Charles Minard. So you see the size of the bar represents the number of troops during the invasion. The troops started with 420,000 soldiers. The light color shows advance into Moscow. And then the black line shows the retreat home. During the retreat, the temperature is also plotted on the bottom of the chart with some specific scale. So we can see that on the retreat, many troops were lost when they had to cross the rivers in the freezing temperature. So you can see lots of information is presented on this chart from different dimensions. So including temperature, number of soldiers, directions, etc. The shape of the, so in this chart, we can look at that the distance scale on Minard's map is shown on this map. So you can see the overall distance traveled covers from Lithuania to Moscow, which is about 1,000 kilometers, which is about 600 miles. This is like the distance from Dallas to Nashville, and then came back. So this is probably the same distance that was plotted on Charles Minard's visualization, which is about the distance between Dallas and Nashville. It's about 600 miles. So this version was created in SAS, showing an animation of the march of Napoleon's invasion. It shows the timeline, the dates, and the temperature. So the use of two colors to indicate the the invasion and the retreat. So here is a redesign by John Boykin based on Charles Minard's data visualization. So he made this in a circular format, try to give some specific information about the shrinking of the number of soldiers. So started with 422,000 and ended with about 10,000 people eventually. So major cities and days are also plotted along with the temperature. So in addition, there are some overall statistics at the bottom of the chart we can see. So about 190,000 people captured, 125,000 killed, and 100,000 died of cold and sickness. There's also many other people actually trying to redo this famous visualization. So there's a website I want to show you. It's wait a minute. It's called dataviz.ca. So if you can actually Google it and get to this website. So a lot of people try to redo this Minard's graphic work. So this webpage summarized actually what have been done. So like this one called Mathematica graph, they did this with Mathematica. And then the people trying to use different platforms like R, SAS. So even to animate. So we saw this animation already. So this is animated version we saw already. And there's 3D cube. And also this one focus on the human side. We also saw this one, the drill down SAS GMAP. So do you think this is the best statistical graph ever done? Do you agree or not? So not everyone actually agree that this is the best statistical graph ever done. So some people even say this is one of the worst graph ever made. So because they believe that there may be too much information being presented on this graph, it makes it difficult for people to interpret in a short amount of time. So instead, they believe that it should be like this one in order for people to quickly catch the meaning of this graph. So this person says they prefer to show the data like this. So this may be useful for the executive to quickly understand the outcome of this campaign. Okay, so this concludes the first video. I'm going to talk about data quality in a separate video. Let me know if you have any questions.